Okay, so we've already figured out in the previous video that the power output is about 1,016.36 watts, right? And I probably don't need all that precision there, right? Now remember, we got it from this formula, right? We've got mgh over t, right? So we want to find the uncertainty of this. Let's assume that gravity is not uncertain. I'm sure there is some uncertainty, but let's ignore the uncertainty of that, right? So what I'm going to say is that the uncertainty of the power is to the power I calculated as the uncertainty of mass is to mass, plus the uncertainty of height is to height, plus the uncertainty of time is to time, right? Okay. And then, the question is there an uncertainty of g? If there were, if we were on a planet that had, very strange densities in the Earth's crust and gravity changed a lot, we could add that in, but we're just not going to, okay? But keep in mind that Anaconda Corporation, I know in the 70s, would fly these airplanes with gravimeters over northern Wisconsin. They're looking for dense parts of the Earth's crust. And what they did was they just measured the acceleration of gravity very precisely. And from that, they could make a map of where gravity was just incrementally stronger. But let's just guess that it's, parts in 10,000, and so we can ignore that, okay? But this we can't ignore, okay? So we have a healthy uncertainty of mass, healthy uncertainty of height, healthy uncertainty of time. So what I'm going to do is set this up, right? The uncertainty of power over, and then this is the power I calculated, right? So make sure you show this calculation very clearly. Equals, and then what's my uncertainty of mass? 2.3 over 76.4. What's my uncertainty of height? 0.5, which is, pretty generous. Your uncertainty of height could be much smaller than that, especially if you have a tape measure and you can just measure. Okay, let's see. Uncertainty of time is 0.13. This is probably the biggest fractional uncertainty here, or 3.37. So it's a lot, right? And if you want to say that the G is, 9.81 plus or minus probably 0.0505, right? But let's not do that. Okay. So here we go. So remember what we do to solve this is we multiply both sides by 1,016.36. Right? And now we're set. So this guy, I'm just going to take the number on my calculator. So that guy times left parenthesis 2.3 divided by 76.4 plus 0.5 divided by 4.57 plus 0.13 divided by 3.37, right parenthesis. Okay, now let's just double check. I'm just double checking my numbers here. Yeah, I got it. Okay. And I'm getting, when I do this, I get that the power delta P is 181.00 watts, right? Okay. So what am I going to say here? I think what I want to say is I need to make this a two-digit uncertainty. So I'm going to say that it's 1,020 plus or minus 180 watts. And ultimately, I want you to give me a final expression like this. I want you to write it down like that. What is it? And it's plus or minus what? Okay. Notice that I rounded. It's ridiculous to give a ones place if your uncertainty is on the order of 200, right? So I have a two-digit uncertainty. Not so worried that you figure out the rounding exactly. But if you understand that I rounded to the tens place here. And the reason I chose the tens place is that this guy here is I rounded it to 2 sig figs. So 181 I rounded to 180. All right, I got to go teach.